Hello everyone, thank you for joining me. We're going to do a transformation of a basic function to get a more complicated graph. The function we're transforming is actually going to be the x squared function. And I know that because I can see the x squared up here. I can see the squared symbol. So if I'm going to be transforming the x squared function, what I need to know is I need to know several ordered pairs that are on the original x squared graph. So I'm going to use my kind of standard -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. The next thing I need to do is I need to identify all the differences in the f of x equation, the g of x equation, to figure out what I actually need to do to change these ordered pairs. Well, there's a +5 here, there's a +3 here, and there's a -2 here. Each one of those is going to cause a change to the ordered pairs on the original x squared graph. The +5 at the end is going to shift the whole graph up 5 units, but what we're going to do is we're going to add 5 to y. The +3 on the inside of the parentheses is going to shift the whole graph to the left 3 units, so we're going to subtract 3 from x. And the -2 in front is going to do two things. The minus is going to reflect us over the x-axis, and the 2 is going to vertically stretch us by a factor of 2. But we can handle both of those things at the same time by just doing a multiply y by -2. There is a correct order to do these three things in. We should always do horizontal shifting first, and we should always do vertical shifting last. And that leaves this as our middle step, step number 2. Okay, so now what I'm going to do is I'm going to do each one of those three things in order and get a new set of ordered pairs. So here I go. The first thing I do is I subtract 3 from all the x's, but I leave the y values alone. It's going to be -5, 4, -4, 1, -3, 0, -2, 1, and -1, 4. That actually does it for the x's. Now my second step is to multiply all the y values by -2, but I leave the x's alone. So -5, -8, -4, -2, -3, 0, multiplying 0 by -2 doesn't change it at all. -2, -2, and -1, -8. All right, one more step to go, and that's we just need to add 5 to all the y values, not changing the x's. So that's going to be -5, -3, -4, 3, -3, 5, -2, 3, and -1, -3. What you can do after you get these 5 ordered pairs, or how many ordered pairs you have when you're done, is you can take one of the x values and plug it into the function f of x and verify that you get the correct y value. It's a good safety check to do. So if you want, you can check, and each one of these ordered pairs in the last row should satisfy the function f of x up here. So that's a good thing to do if you're in a testing situation. All right, let's plot our points on the coordinate system. Scroll down here so we can get a good look at our coordinate system. And we've got -5, -3, 1, 2, 3, 4, 5, 1, 2, 3. There we go, right there. -4, +3. Okay. -3, 5. Up there. -2, 3, right there. And -1, -3, right down there. So we can still see the parabola shape. Just remember, parabolas are not pointy. They're nice and curved. So I kind of do the curve up there like that. Come down here best I can. And get the graph of the parabola. One of the most important points, and I'll be right back to the graph in a second, is this 0, 0 point, which became the point -3, 5. So we put that right there, and this will actually allow us to identify the range of our graph. The domain is -infinity to infinity. That hasn't changed from the original, but the range is now -infinity all the way up to the y value of 5, including 5. You can see that we are still looking at the graph of a parabola. The general shape of the graph should not change. It might get flipped or stretched or shifted, but the general shape should remain a parabola. Okay, thanks for watching.